Hello, everyone. My name is Amir. Welcome to our second part to our Java Basics sessions. Just want to make sure that everyone can hear me. Can you just please let me know if you can, in the channel, if you can hear me and if you can see my screen. If the screen is a bit blurry, don't hesitate to change your settings to a higher quality. We'll be starting shortly. I'm just giving one and two more minutes for people to join, and we'll just start. Thanks for letting me know. Actually, I had forgotten to. Okay, now you should be able to see me. Oh, sorry, see my screen rather. So can you? So Byte Tonight and Simc, can you guys see it? Yeah, perfect. All right, awesome. Awesome, great. So just giving one quick minute, and then I'm just going to start. Just. Just going to start. Okay, so welcome today. For those of you who didn't see my previous sessions where we touched on the basics of Java and the basic constructs and some types and things like that, I would recommend that at a later time you go and watch that video too. If some of the concepts that I had touched upon in the last session, I will not be repeating too much here, and for the interest of other people who have already watched it. And so just before I start off, I'm keeping an eye on the channel, so if you have any questions, if I'm going too fast, please let me know, and I'll happily try to re-explain any concept that might have not been clear for you guys, okay? It's very important that you go maybe with less information, but that you do understand whatever I've explained. All right, fantastic. So let's get cracking. Today's all going to be about coding. So we're going to be writing a software for a vending machine, okay? So I've written up here on the screen, as you can see, it's a very simple requirement that we have gotten as software engineers. And there's a company called SodaPop, and they have a vending machine, and they would like to, they have tasked us to write a software for their hardware, which is a soda vending machine. So they gave us some very simple requirements, which are written on the screen, and we're going to go quickly through those, and then we're going to start coding the software that's going to run on this hardware machine, okay? So we're tasked to write the software for a new vending machine that this company has made. So the machine is called SodaPop, and there are 4 drink options that are offered in this vending machine. So as a typical vending machine, you can imagine that there are going to be like 4 buttons next to, and each button there will be the name of the drink, and there will be the price associated to it. And the other requirements that we can see is that each drink has a maximum capacity of 10. So we have there are only 4 buttons, 4 slots in this machine where you can put coins, and the prices are indicated here between the parentheses. And each of these drinks will have some kind of stock capacity, which is in their hardware is a maximum of 10. Okay. Now they've also tasked us from an interaction point of view. They have 2 ways. They've decided that there should be 2 ways to be able to interact with this machine, and there's a maintenance interaction. Mostly this will be, I guess, for their for the technicians that go and sort out any kind of technical problems with the machines, or who replenish the stock of the sodas. So for that kind of interaction, they have required that we should be able to the maintenance people should be able to turn on the machine, of course, and turn it off. They should be able to replenish the stock, and they should be able to retrieve the cash. And when the stock level reaches 3, so if it has 7 drinks have been sold, so on the 3rd we should send an alert. So that's from a maintenance point. And then from a user interaction point, meaning from a customer point, the customers should be able to see the price of a drink. They should be able to put coins in to buy a drink, and also be prompted to put in more money if the money that they have put in is short to the total amount of the drink value. Okay, so this is like a very basic requirement. And there might be more things that we haven't seen. And we are just going to then improvise. And if there were some condition or edge cases, obviously there are a lot of edge cases here that they haven't specified. So we're going to be building those also. So one thing to, just before I move on forward here, it is very important for you who are going to be developing also software in companies in the future, is that you will see, for those of you who haven't really had this kind of interaction before, is vital when you are given a spec. So for example, this is what you have on the screen right now is called a spec. So a business specification of requirements. It is very, very important that you go through the whole spec when you're given a task, that you understand it fully, and also that you ask questions. For example, here, there could be many other questions that could be asked for, like, what if the person just puts in half of the amount? So if the person was buying Ice Storm and they only put in, let's say, 40 cents or 45 cents, what should happen if they don't have any more change? Can they cancel? Like, it's not specified here if they should be able to cancel and get their money back if they don't have enough change, for example. So this is just one example, but there could be many. So always try to develop a habit of, when you're given a specification or something, try to get all of the answers up front as possible. Ask questions. Okay, great. So as I mentioned to the channel previously, today we're going to be making the software using a test-driven development. Okay, now I want you to bring your attention to the left-hand side of my IDE, and you guys must have seen this also in your Android Studio. There you have 2 directories that are created, one for your main source code and one which is for the test. Okay, now notice one thing. Our rule in test-driven development, when you're writing tests, the idea is to say that we do not worry about writing immediately the implementation, or any implementation that is going to be generated, that is going to land in this blue folder, which is a source folder, Java, will only be generated because we have written tests to validate some business requirements from this folder, the Java folder, the green one, which is the test folder, the test source code. Okay, so as a rule, and we're going to be very purist today in this session, so I'm not allowed to do this. We're not allowed to go and say new Java class, and I'm just going to add a class like that. We're not allowed directly to interact with this section of the IDE, of the source code. If we had to create anything, it will be done through writing tests. Okay, so this is a very important concept. Okay, so let's start writing the software. Like, how would we go about doing this? So first of all, you can look at it from 2 angles. You can look at it from a very data-oriented angle, or a user contract-driven angle. So let me explain. Let me clarify that. What do I mean by a data level? So for example, data is anything that's going to be representing your business domain. So for example, we could introduce here a concept of coins or change, for example, to represent money. We could create a class called drinks or soda to represent these entities. These are, after all, soda and drinks that the business sells. So we could start maybe focusing on creating the lower levels of your data layer. If so, at the most bottom layer, you'll have your data, so which would be, let's say, pretending to be interacting with a database. So you would have your POJOs, your plain old Java objects, which are going to be just containers of data, and then you can work your way up. The other way, the contract and the more preferred way, is to say, well, I'm not going to worry about these low-level details at the moment, and I'm going to guide the development by thinking about interactions, about use cases on how users are going to be interacting with the system, right? So the contract-driven approach would be to say, well, I'm going to start actually from the outside and go down towards the bottom, toward my data elements, and that will be driven by the interaction. So for example, we could say, let's write a a contract or an approach where we're talking about the maintenance, and we're going to think about, okay, if we want to turn on a machine, we should first forget about what's going to happen to the internal state. We should first think about, okay, these are the API that we should be developing that will give us the capability to turn on a machine, right? So just before that, you can see, well, I have to introduce also a concept of a machine. So we're going to go from the outside here, and we're going to try to look at it from a user's perspective of how people are going to be interacting it. So, okay, the video seems not to be loading. Okay, are other people also having this issue? Can you please reload your page and let me know if you're still having a problem? For me, it seems that it's okay. Let me quickly just check also something else. I'm just gonna quickly see, but so just bear with me 1 second. I'm also just checking that I can see. Okay, wait. Let me. Are you guys able to see this, or are you having a problem? Let me quickly go and stop sharing. I'm just going to restart sharing. Okay, just let me know if this is okay now. Hopefully it should be working. Okay, so just let me know if this is So, like I said, we're going to attack the problem from a user and from an outside point of view and look at it from an angle where we're going to first think about the interactions, and then eventually we're going to go down at a lower level. Okay. Great. So let's get started. So the company has tasked us to write a software for a vending machine. So you could think that we're going to have obviously a concept of a vending machine, and we're going to start with that. So let's create the package here, and we're going to say com soda pop, okay, and I'm going to call this service. So I'm going to call this core, okay, and we're going to introduce here a class called vending machine, okay. Now, and this is going to be vending machine test, okay, vending machine, because we are writing only tests first. All right. Okay. So now one thing that's important is that for those of you who saw my previous lessons, the interface is very important in Java, and you should always try to abstract away whatever your interactions and the system that you're building with is to use interfaces. Okay. So we're going to introduce as much as possible where it makes sense, and as much as possible we're going to use interfaces. So the first task that we have to do when you look at the requirements here is that if we attack just the maintenance requirements, we should be able to turn on the machine and turn it off. Okay, so we're going to first write code, or at least first a test that can make us prove that our machine can turn on. Okay, so we're going to write a test here, and we're going to call this method. By the way, so I'm using JUnit, okay? JUnit, you can import this in your Gradle build file for Android. I'm using Maven here, so the dependency that I've added here is called JUnit. I'm using 4.12 is the most recent one. And so Maven, for those who don't know, is just like a Gradle, but is made for Java, and it was way before Gradle came to be. And it's a very cool tool. It's a framework that enables you to do builds, packaging, does a lot of other great stuff. So I'm using this right now for my Java project. You can do that also when you do that in your IntelliJ or in your own. You can just say new project, and then you can just say Maven right here. You can select Maven, and automatically the IDE will structure your project to be able to use Maven. And then you just go into your pom.xml, and you can add all of your dependencies here. So I'm using JUnit for testing. So that's what I've added here. So now coming back to, I'm going to still need this. So coming back to our test. So we're going to write a test to prove our first requirement, which is turn machine on, okay? Now notice how this is empty, how this directory is completely empty. The idea, like I said to you, you're not allowed to go in here, and we're not allowed to go and add ourselves anything. Everything should be driven by the test. And you'll see how we're going to populate this folder slowly but surely, okay? So turn machine on. So let's reintroduce a concept of a vending machine, right? That's what we're talking about. We should have a vending machine, right? And we should be able to say new vending machine, and then we should be able to say, call a method, for example, for the time being, I'll say on to keep it simple, okay? And this should, let's say, now it could return two things. It could return to us a Boolean to say, turned on is on, for example, right? Or we could just say a timestamp. So for the time being, it's not relevant or whatever. So I'm just going to put it to a timestamp. So I'm trying to say turned on at. So this is going to be a timestamp that I'm going to return here, okay? And somewhere around road, I'm going to assert this that this is that the machine came on, okay? So one quick thing I'm going to do here is I'm going to go and I'm going to look for so fest assertions Maven dependency. I'm going to add another tool that I like using a lot. I forgot to add it up front, so it's called Fest. You'll see why I'm going to be using this. It just makes writing testing code a bit. Okay, so video not loading. Okay, this is not great. Are other people having the same problem? You guys try to refresh your page and see. Could you guys try to see if it's all good, or it seems all right on my end? I've just done a quick. For those of you which are having, just make sure also that you're the live, so you're at the end of the streaming bar. You should be at the end of it and not like in the middle. Otherwise, you'll be going back. You'll be going back into the session. So just just make sure that you're at the slider on where you are is at the completely at the end on the right hand side. All right, so we're just gonna. I've just added here Fest so that I'll be able to write a bit more easier assertion, and I'm going to show you how. So coming back here, so we're going to turn on the vending machine, right? So now remember one thing. As I told you previously, it's very important that when you're writing your abstractions that you always think about contracts and how you should be using interfaces and defining contracts rather than thinking about the technical implementations, okay? So when we're going to write vending machine here, vending machine is going to be an interface, okay? Because I want to think in abstractions, okay? We should always try to think in abstractions when we're writing object-oriented code. So a vending machine, regardless of what kind of implementation comes to it, we're going to define the contract that it has. Now, note the interesting thing I'm going to do here now. Right now, I'm writing the test here, right? But this vending machine interface or class or whatever we'll be building eventually is all going to be code that should go into this blue folder, which is the source code folder, and not the test folder, right? So I'm going to create the vending machine right here. So I'm going to create an interface, right? And the key thing here, though, is I'm going to change my target destination, and I'm going to put this into the main folder here, right? So now when I'll click this, the class, at the moment it's a class, it will appear in the Java folder here, okay? All right, so if you look at the Java folder here right now, it's vending machine here. So I want this to be an interface because this is going to be our contract. So we're defining a contract. Now, because the software we're making is for SodaPop, this is a SodaPop vending machine. So for the time being, I think a reasonable naming convention or naming of my concrete implementation, because now we're going to, obviously, we have to instantiate an object with some internal behavior. I'm going to call it the SodaPop vending machine. Okay, so SodaPop vending machine. All right, and the same way, I'm just going to create a class here, and I'm going to make sure that it goes into the blue folder here, which is my source code. So you can see now how the code is coming and growing here, but we are never ourselves adding anything manually. The test is putting it in there for us. Okay, so we said that the requirement asked we should be able to turn on the machine right here, right? So we're going to write a test here. We're going to introduce a method in the interface, okay, which is now going to be able to so we could just write something like this: returns the start time of the machine. Turns on a machine. And I would always recommend you to write very clear and concise documentation on your interfaces. Okay, so that later on, the code is always the main reference as to what the code is doing at any point in time. Documentation, if you write it in a Word document elsewhere, will fall out of date. It won't be maintained, etc., etc. So the best thing you could do is just write nice documentation for your APIs here in your code, and that will be and your fellow developers will thank you, and you'll thank yourself when you come back a couple of months later to your code and you won't understand exactly what's going on. If you have put in nice documentation, it will be much easier to interact and start back again where you had left the code. Okay, so let's come back here. So we're just testing, and as developers, sometimes it's good to be lazy, and we're just going to write enough code. And this is a very important concept. Just write enough code just to make your test pass. This is the philosophy of test-driven development. And also, like when you're writing code, you should not write unnecessary code, right? You should only write enough code, and that won't die, that meaning that it will never be used or called, and just enough code to make your requirement work. So right now the requirement says what? It says, well, turn on the machine. Okay, so we're calling the on method on it, and we just want to assert that this value is not going to be 0, it's going to be greater than 0, right? Because it should be, it will be a timestamp, but for the time being, we're going to say that, assert that. So this is where I'm using for the FEST, that framework I called in. It just enables me to write a bit more fluid type of testing assertions. So I can just say, for example, assert that turned on at is greater than, for example, or is not equal to, not null, for example. I could say that, for example, but because this is a number and I want to make sure that it's going to be greater than 0, well then, so FEST gives you this fluid kind of API. It's called FEST assertion. I'm quickly going to show it again. So it's called FEST assert. So if you want to look this up in your personal time, feel free to do so. Okay, I'm going to have a quick look at the question. So why is JUnit being used instead of just Java? Well, JUnit is a testing framework. So Java is a language, and JUnit is a framework that is built with Java, and it helps you write unit tests. So for example, when you're using an annotation like this, add test. So for example, if I run this now, automatically the framework is going to analyze this annotation as test and then run it. Okay. So for example, when I ran this now, because I've implemented vending machine on this class, I need to provide the on method to it. So when I run this test, so then this will run a unit test here that you can see in the bottom left-hand corner, and you can see that it says to me right now, assertion error, actual value 0 should be greater than 0. So to able to fix this test, so I'm just going to continue. Before I continue, I'm going to take some more questions here. So it's not. So yes, it is like Espresso, as it's a framework, and Espresso is a framework for UI testing, right? It's not for unit testing, but it's for UI testing, and it's made for Android. So absolutely. So in that sense, it is similar. JUnit is similar to Espresso, but JUnit is just for core Java. So what I've written right now here is just core Java, and even when you in your Android code, when you just write just pure Java in some parts of your logic, well, you could just write unit tests for that, and then you would be using JUnit. But if you're doing any kind of testing for your UI and you want to bring up your application and in the emulator and just, simulate some kind of interaction a user would be doing, then you would use Espresso for that, for the UI part of it. Okay. I hope that clarifies your question, James. Now, coming back to this test, so we're going to say assert that turned on at is greater than 0. Okay, so we ran this test, right? So we ran this test, and it says actual value 0 should be greater than 0. Now, remember what we just said earlier, right? We should only write the minimum amount of code, right, that is going to make the test pass. So right now, and the reason why you do that is that you want to add a lot of test cases to stress your code to make it at the end behave like it should. So for example, if you look back at the API here, it's the start time of the machine, right? That's the value that's returned, and this method returns along, right? So obviously, if we return 1 here, although that would be valid, that would be like 1970, right? As a date, for example, if we converted this as a timestamp, so if this was a timestamp, so return the start time timestamp, that's the idea of the machine, then obviously 1 is a valid value, but it doesn't make sense because it's way back in the past, right? So technically, this value of 1 is not a great return value, although it's sufficient. If I run the test again to make it pass, and as you can see, it's all green here, and with the checks, which means that the test passed basically, right? So the philosophy right here is to say, I'm going to just write the minimum amount of code, and if I need to write anything that has to correct it even further, well, I should be writing a test for that, and I need to stress through the test, the code, and make changes that are going to be required, okay? So for the time being, our machine has been turned on, okay? So if we wrote, a main method somewhere and we ran our vending machine, well, our soda pop machine would turn on. At least that is guaranteed. So I'm just going to add some more, some more output, let's say, to the code here and say turning on vending machine. Okay. So if we just reran this test, you would see in the output here, turning on vending machine. Okay, and we could just say turning on vending machine at, and we can just say this time get current time millis, and we could just rerun this, and that will give us the number of milliseconds which represent this moment right now. Okay, but we have written enough code here just to make the test pass. Okay, fine. Now, how do you stress this? And this is the interesting part, and this is what the philosophy of unit testing is, that how do you test this, right? So one way to do this is, for example, we could write a test to say turn machine on, right, with time check. Okay, so this time we're going to be testing and making sure that the value that is returned is not some bogus time that has lapsed, but something a bit more specific, just so that it's more clear to a real approximation of what we would want. So we could recreate again this vending machine and say vending machine new soda pop vending machine. Okay, and we can say vending machine turn on. Okay, so I'm going to introduce here a variable turned on at. Okay, but this time the assertion is going to say, well, assert that turned on at, right, is greater than. Obviously, if I said put greater than 1, then that is not great, right? I mean, that's not. I mean, it won't resolve anything. Why? Because we could just go into our implementation and just say return 2, and that would be perfectly valid. And if we came here, if we ran, both tests will pass. Both tests will pass here, right? And that's not the point either, right? The point is that you're stressing your code, but you're trying to get to the real thing of how you would expect it to behave, right? So what you would want, because between the moment that the time is going to be turned on is going to be a couple of milliseconds. So what you can say is that I want to make sure that the time that is returned is greater than the current milliseconds right now minus, so let's say the execution time might be, let's say, 10 milliseconds. So I just want to make sure that if I took away the time right now and I remove 10 milliseconds, well, then this time should have been greater than that, because the moment I just turn, because the time it will take the compiler, or the execution, sorry, rather, to go from line 24 to 26, hopefully it will be faster than 10 milliseconds, right? So if we write the code this way, this will fail, because right now we've hard-coded 2, right? And so we're going to now, so now you see we're stressing the code, and because we were already printing out the current time milliseconds, I'm going to just extract this in a variable, and I'm just going to return that, right? And now I'm going to run the test again, and now the test passes. So now you've seen that how the first test is still there, still valid, it's still greater than 0, but now we're also more closer to the real value. And we've shown that the current, by using the real deal, which is the current time millis. Okay, so now we wrote 2 tests, and we're on turning on the machine. For the time being, it seems that we're good. Okay, great. So right now we have finished off this feature, and we can now create a soda pop vending machine that turns on, but that doesn't do anything. But okay, it can turn on. So turn machine off. So quickly moving on, we're going to do the same thing now. We're going to say turn off the machine, same way. Turn machine off, and this is going to require, again, a vending machine. New soda pop vending machine, long turned off at, and vending machine off. Okay, so now once again we're going to see we're creating new code. We're creating new code here once again through our tests. Turns the machine off. Okay, and then the stop time. Okay, let's go back here, and obviously if we're going to assert this, we're going to just say assert that turned off at is greater than system time current time milliseconds minus 10. Okay, and we're going to run this. Of course, there will be a compilation error because we haven't implemented off. So now we'll be forced to implement off and provide the data. So right now I'm just going to go straight now to current millis. I'm going to rerun this. Okay, and then hopefully this works. Okay, turn machine off. So now the machine can be turned on and it can be turned off. So I'm just going to copy this here and just say also that, so actually I'm just going to do this. And I'm just going to turn off the machine here. Okay. And we're just turning off the machine. Okay, so turning off vending machine. Okay. Now, one thing, because right now we have written tests and all our tests passing, and the cycle of a TDD way of doing things is that you write a failing test first. That there are 3 steps to it. You write first a failing test, which we did at the first. If you guys remember, when we wrote this test, we obviously created these interfaces, the implementation. We ran the test. It failed because the value initially was 0, and we wanted something greater than 0. Then we changed it, and it passed. So the first step, we wrote a failing test. Second step, we fixed it by writing the implementation. Here, as you saw, we provided value. Okay. And the third step in this TDD cycle is refactor. So at this point where we have written the test, sorry, we have written a failing test, we have written the implement. So right now we just wrote a test, a failing 1, off wasn't working, we implemented the off, and now the test is passing, right? The test was fixed. So now the step 3, we are allowed to refactor. So one thing we're going to do now, as you see, is that there's a proliferation here of new, right? So this is not good. This is not a good thing. We shouldn't be spreading out new commands in your code. So if you're doing that, you should maybe refrain from doing so, and you should maybe wrap your construction into or a method factory pattern or through a factory. Okay. So for the time being, to keep it simple, we're going to refactor our code so by refactoring code, you're only allowed to change names and the structure, but you're not allowed to add new functionality, okay? So we will not be able to return new values or change anything. We can just move structurally the code and rename variables to as much as we want, but we're not allowed to add new features, okay? So what we're going to do here is a structural change. We're going to introduce a method called create, right? Rather than calling new all the time, because we want to encapsulate the new creation within a method. So we're going to create this method. It's going to be a static method, and this will return a new soda pop vending machine object. Okay. So now the value of this is that, first of all, the value of this is that we have given a meaningful name. So when someone will call create, they will instinctively know that it's going to be about creating a new object, right? You could add more comments here, but the name is specific enough. And later on, if we need to add parameters or whatever, we can add maybe more constructors with more meaningful names, depending on which kind of machine, maybe with a different state, initialized with a different state. If we wrote a constructor, and which will, because we want to make it private so that now no one will be able to call the constructor directly, so we're going to make it private. Okay, so now one of the cons of a constructor is that it has to have the same name as the class. Whereas if you create this factory method pattern creation, the factory method creation pattern, is that you can just create a default machine. We could name it whatever we want that we find explicit, and then people would just be able to use that to get an object of type vending machine. Okay, so right now this is a soda pop vending machine. It's a good practice to return, rather than returning the interface, is to return the concrete type. It's always good. But when you use objects, always try not to use their concrete implementation. Always try to see if they have an interface. If they have an interface, always try to use their interface. It's better practice because you should always think in abstractions. Okay. Now the impact you saw is that because we've made our constructor private, now everywhere in the code. So right now we haven't written much code here on the left-hand side that is yet using the soda pop vending machine, but if it would be, then everywhere where we would be making a new call, it would fail, and now we would be forced to say create. Okay. So now we're just doing create. So now all the news have gone, and we can just, and always remember, when you make small changes, run often your test. Okay, just run them like that, right? So that way you know that you're making incremental changes, and your code will, if it fails, then you can back out and see what you changed that could have broken something. Okay. Now, one other thing, we've done this, so we've made a private constructor, right? So that no one can call it, so it doesn't matter. But we've just created a private one. It doesn't do anything. No initialization here, which is fine, which is absolutely fine. But that we have enforced that no one can use new anymore. They have to go through our own creation mechanism. Okay. So one other thing, so this is right now we are just refactoring, we're just making structural changes, we haven't added any behavior. Good. One other thing, the reason why I'm saying that you always return, you return the concrete type here, but you always write your code to the interface here. Okay. For example, if in your code ever you do this, if you're using an array list of strings like this, okay, I don't know, accounts, new array list, right? This is wrong. You should never write your code like that. I'm not saying never. I mean, there are always some extreme edge cases that you will, but preferably don't write your code like this. Always write why. This is absolutely fine, and this will compile. Like if I ran the test right now, it wouldn't complain, right? The code would work. But you're writing to a concrete implementation. Array list is a concrete implementation. Soda pop vending machine is a concrete implementation. So you look at the array list class, you look at is it implementing any interfaces. It is. It implements list, random access, clonable, etc., etc. So, and also it implements an abstract class, which is also fine because that is just like an abstraction. So you cannot instantiate it, which would also be fine. But prefer interfaces. So the right way would have been is to write it this way. The reason being is that later on in your code, if you think that maybe a linked list would be better, this would work. You could just change, because if you pass in this, if you injected this variable into your code in other implementation and it was used further down in your code, this you could just change at the point of creation, like we did an array list to a linked list, and this would just work without any problems. But had you done array list here, right, then your whole code base, this would not work, right? So you could not swap in and out implementations to a same abstraction because you're using a concrete type. So this is a very, very important concept to grasp and should be always mindful. So like I said to you guys earlier, we're taking a concrete a contract user interaction driven approach. So always think in abstraction in contracts. So we're writing a contract. Here our contract is vending machine. A vending machine can turn on and off, right? Later on in our, if our software works very well, which it will, and so if some other fizzy-wizzy vending machine company comes along, we can actually reuse our software and give it to them. And all we will have to do is that if they had anything specific, we would not create, we would just replace the Soda Pop vending machine implementation and create a new implementation called fizzy-wizzy, you know, pop vending machine, and that would just work also in our code through the whole code base. Okay, that's a very so important to we do it this way. Okay, I'm going to take a quick question on the channel. Sometime in the future, and we use some functionality that only arrays implements some that right. Yeah, and that so and absolutely. So absolutely. So Flynorg, that's a very good question, and that could happen. Although I would say that would be that would be the exception rather than the norm, right? But it's an absolute valid question. But in that case, what you could do is that you would, if you knew that it's going to be an array list, you could cast or vary down at the point at which you want to use that array list and not a linked list, right? Then, you know, you would use an array, that array list implementation. But what you could also do is rather than at that point, if you're using array list, in that case, I would recommend that you wrap this whole thing behind your own interface, and that behind your interface you change and you pass in your own custom interface type rather than a list type. You pass in your own type, and then you can just change your type at that point. But because if you're using something very specific, so let's say in this case array list, that means already your part of your code is tightly coupled to the array list type. So it's up to you. You could use only array list, which I would not recommend, or you could just, in that part where you're going to make a specific array list call, you could use maybe your own interface in there, and then you would manage that, you know, swapping or whatever you have. Because if deep down at a third or fourth level in your code, you're using array specific, making a method call on an array list, well, your whole code base will blow up at that point, right? I mean, you'll start giving anyone who uses it and uses linked list, because the contract is list and not array list. Well, they can put in whatever is implementing list, right? So you should be wary of that. If you find yourself in that scenario, maybe it's better to create a new interface of your own design and just wrap inside the implementation something specific like array list, or you know. So, okay, now we've done this, okay, time is passing by really quickly, so I really need to move forward. So we've done this on and off thing, right? Okay, great. So now what do we want to do? So we've done this, we've done turn on, turn off, replenish stock of a given drink. Okay, so this is where stuff starts to become now, you know, interesting. But now, just one thing before we part here, right? You'll notice that right now we don't have a concept of a state here, right? Right now we're just returning numbers, right? So another test we could add is that we could prove now, and once again, it's look at how we're stressing the code, right? It's about not writing new implementation directly ourselves, but it's about writing a test that proves that, you know, that we don't have that the state of what we're implementing is correct. So for example, if the machine is off, that means the state should be off, right? It cannot be on, for example, right? So for the time being, though, I will be, because I said that we're going to be very purist today in development mode. They haven't asked for a status yet here, so I'm not going to do that. We could have written another test here to make sure that if the machine is off, we would say vending machine state, and it should also be like off, right? We wouldn't call off. We'd say get state, and it should be like off, for example, right? So that could further also make us then introduce some kind of Boolean value in here, right? A state that would say, you know, my state, for example, right? Am I on or off, for example? And that way we could check, do we need to turn it on, or because right now we don't know if it's on or off, right? It just returns time, so there is no concept of a state. So actually, you know what? Let's do that, right? So you could say check state of machine, right? So now one other thing, right? As you can see that there's a lot of every time we're using create, this is unnecessary. So JUnit gives you a help here where you can just say, we're going to say public void I just like calling it always setup. It's my convention. You can name this to whatever you want. That's not important. The important thing is the annotation that you use, and it's called before. So what before will do is that whatever, you can only have one method annotated with add before, and this add before actually will run whatever code you put in it before every test method. So if we have right now here 4 test methods, right? We have 4 test methods. For each test that method is going to be run, setup is going to be called. So what I'm going to do here, right? We're going to move the vending machine here and just declare it once. That way, all of my tests now, all the other places where we have declared we're using one, they will just inherit the global variable here that we have defined, and every test of the framework, the JUnit framework, will automatically initialize this object back to its initial state, right? So that we're on a clean base when we're running the next test. Okay, so right, and always just have this habit of running your tests often, right? So okay, interesting. The machine off right now is not working anymore. Interesting. Like, why is that the case that now off is not working? We just made a simple change. So we're creating the vending machine here, and so we turned the machine on. Time check. Turned off is greater than. Did it go too quickly? Maybe that's the thing, that maybe it ran too quickly. Yeah, that's the thing. It ran too quickly. So maybe we need to say 20 milliseconds, right? So this could be a scenario where, we might need to maybe revisit the test a bit more. Yeah, exactly. Yeah, absolutely, Flanwork. So that's why it's taking. So this is something that we could come in and fix, but that's not the key point. So I'm not going to worry about this right now. So check the state of the machine, right? So if we have the vending machine right now and we just turn it off, let's say, right? So the key thing now we're going to introduce, let's say, state. So state, right? And the state here, I would say, is, so we could just maybe say, for example, vending machine state here. Okay, so state. So what we're going to do here now is that we're going to define an enum, okay? Because now, why am I doing an internal one? I could have created an external one, but the reason why you do this the same goes for in inner classes or the likes, is that I want to express to someone who does not know my code that the state that I'm defining here is tightly linked or related to the vending machine, right? So this is one way of doing it. I'm not saying this is this is how I like to think about it. So I could just say off or on. So I've given my states. So I could have very well just created this maybe externally, and but I'm just doing this for the time being. You could do this very well by creating another enum. That's absolutely fine. I'm just trying to make a point here by the way I've written my code, saying that if this enum is within my vending machine interface, I don't want to put it in my concrete implementation, because like I said, if someday we created a fizzy wizzy vending machine, well then that state will then have to be duplicated from the soda pop. So it's better to directly put it into an interface, and that way that interface is going to be common to anyone who wants to create an implementation of our vending machine. They will inherit also the same states, which are just generic. So every implementation should be using the same state concept. So here in our implementation here, once again, we're going to be now implementing a method that will return the state, and this time now we're going to be obviously stressed. Now this is again, right, we're stressing the code, we're adding a state to it. We want to prove that what the tests are, the tests are requiring us to add only the required implementation. So here, if I turn it off, then I should be returning state off. But obviously, at this point, what we should be doing, so let's say I'm going to say state off. So here, the state, I'm going to get it back, and I'm going to say assert that state here is equal to, right? Is equal to, and it should be state dot off, right? If the vending machine was off, for example. So if we run this, that is fine. But if we do the same thing now with check state of so here I'm going to say of machine, of off machine, and here's check state of on machine. And obviously, if I turn this on, then now the implementation is going to break, which is a good thing, but that's what we want. So if you ran this, obviously we've hard coded off, so this will fail. So now we have to go in and we have to change our implementation. See, so unless we hadn't written this test, we wouldn't have been obliged to go now and make the change that I'm about to make, because no test is requiring us to do so, right? So now what we're going to do is, because if we turn it off, we have to keep us a concept of a state here. So private state, right? And we can just say by default. So now, for example, okay, in the comment I said there was no initialization value. I can say that by default, if you create a vending machine, then the state should be on. Okay, that's my, nothing in the spec is saying the contrary, and so I am naturally saying right now that by default, once you get a soda pop vending machine, the state is on. Okay, so here what's going to happen basically is that we're going to return here the state, right? Because now we have a state variable, but now the key point to make the test pass and make the other one is also that if we turn it on, we're going to make sure also the state is on, right? On. And if we turn it off, then we're also going to make sure that the state is updated to off. Okay? So now we're going to run the tests again. Now everything is just working now. So we're just going to run all the tests again. All right, so fine, great. So now we have also a real internal state and we can check it. Okay, great, moving on. Where did I, all right, okay, so I'm just gonna back this off, okay. Cool, this, make sure that everything is working. We haven't broken anything, awesome. Okay, one quick thing, just to show you guys, right? So we've done all of this, right? So let's, let me run the test again and run it with a coverage. So I'm gonna run the test here and we're gonna cover, and for the time being, we have 100% test coverage. And you notice, right? Of course, we haven't written much here, right? We just have an interface and an implementation. We have only 5 methods. But note one thing: never did we try to achieve this, right? We never tried to achieve this at any moment, right? We were just naturally writing our code here, right? Just so that it corresponds to the spec, and we're taking our time and we're writing all of these different types of edge cases to make sure that the code is behaving correctly. And as you can see, if you just look at the coverage report that we just saw, right, we have 100% without doing any effort here. So for the time being, it's okay. Obviously, with time, this might drop, but for the time, we're good. We've got 100% lines covered. That's fantastic. So let's keep on going. Okay, so replenish stock of a given drink. Okay, same thing. So is it a vending? Now, one of the things now, this is a part now where, because we're adding more behavior, you should always be thinking in an iterative manner. Single responsibly. For those of you who saw my previous video, I introduced the concept of SOLID, right? The SOLID principles. It's an acronym, okay? And the S in SOLID means single responsibility. A class should do just one thing and do it well. All right. So we have a soda pop vending machine. Should we introduce a concept of like stock here or not, like replenish stock of a given drink? So we haven't even yet introduced the concept of a drink yet, right? But we see that from a maintenance perspective, this is a big chunk now suddenly, because we have now before even we can talk about stock, we have to now introduce a concept of a drink and things like that. So single responsibility will. Now, the single responsibility flag goes on in our head, and we're saying, okay, for the time being, let me take a back step here and let my vending machine alone. For the time being, we just looked at the state of the vending machine, but right now the stock management isn't very clear. So for the time being, we're going to go and we're going to introduce a new concept, and we're going to first of all work with that concept, okay? So remember what we said though, right? We said that the idea was, we are driving this by a contract, right? So right now, our main interface of the system is the vending machine, right? So we could argue it 2 ways. We could do it 2 ways, or we can just first think about how do we design the stock, and then we plug that into the machine, or we can go from the machine and then say, okay, now we have written something here. First, let me write the implementation of the stock management, and then I'm going to come back and fix the test. So let me do it the other way that the most, maybe the most developers would do. So to show you how I'm telling you to think about from a how to think about from a from a contract driven approach. Okay, so this is how it works. Remember I said to you that we're driving this from the outside, and we're thinking about how people are interacting with our system, right? So a maintenance technician would also interact with our system, where they're going to be creating, interacting with the vending machine, right? So by the way, one thing also to note, right now you can see that the class is now getting more and more tests. There's nothing wrong and nothing preventing you to create another class, making it a more specialist. So I'm going to call this vending machine. Okay, vending machine stock test. Okay, so I'm still going to introduce the same behaviors. Like it's all about the vending machine still, right? It's still all about the vending machine. But it's always nice to have small, concise classes. It's always your fellow developers will thank you. You will thank yourself also later on when you're going to come back to your code. So right now, so I'm kind of breaking this up. I'm just saying that this is just purely a vending machine, and now this is only going to be anything related to stock management, right? So here we're going to add a new test, and we're going to say, okay, now we should be able to. Apparently, the business requirement is that we should be able to replenish the stock of a given drink. Okay, so there's a lot of concept here involved, but let's do this, right? So let's just try say check stock of drink. Okay, so this is so we're as you can see, this is now going to introduce a lot of concepts suddenly, right? But which is a good thing. But so obviously the interaction is going to go from the vending machine, and then the vending machine is going to delegate this behavior. And I'll show you how we're going to do this with a test. So we start off with the vending machine here. I'm going to say, so I'm just going to call this, for example, so before we can even talk about replenishing, right, we need to have a concept of first acquiring the stock, right? So this is also coming back to the point where if you would be reading this as a developer, you would go back to the business analyst and say, hey, you know what? I think we need to sit down a bit and jot down and have a bit more explicit, more requirements, because there's some more requirements that are missing here, right? So here, before we can be able to replenish the stock, we should of course be able to see what the stock is, right? So we're gonna say, get stock, and we're going to provide a drink. See, once again, just note how we are introducing concepts. We're not ever going here. This part does not exist for us. The source code is not. Everything is driven by the test, right? You write it from your test. So get stock of a given drink, and this should return what to us? This should, let's say, return to us an integer, right? Current stock, right? And this should be, so we saw that by default, if you created this vending machine, well, we said that the business requirement is that it starts out with a capacity of 10. So that drink, if we started off, we just created a default vending machine here, we already know, like we can already go to the point and say, this is what our expectation is, current stock, right, is equal to, so let me import that, so is equal to 10, right? That's what the business requirement says. So we're just going to fill this up. Now we've written the test, right? So let's fill it up. So I'm just going to do something else here, because I just want my IDE to help me when I'm going to write this method, so that automatically it will pass in as a first parameter a drink type here. So before I do this, because right now it does not know what drink is, right? If we created this like this, see, it's a bit lost. It doesn't know what it should do, right? Because drink is not meaning anything, so it's just giving me split into declaration and assignment, but that doesn't mean anything for it because drink doesn't have a type. So what we're going to do, we're going to say we're going to now introduce a new type called drink, right? And we're just going to maybe create an ice storm drink, right? So ice storm drink. So we're going to say new ice storm, right? And so this once again, as much as possible, I'm thinking in contracts. I'm thinking in abstraction. So we're going to create an interface, and this time I'm going to put this not in the core package. I'm going to put this into the domain package. So it's going to create the domain package for me right here. There you go, drink. Okay, and we're going to come back here, and now we're going to say new ice storm. So automatically it will go, and so it's putting that in core, which I don't want to. I want to put this into my domain into my domain package. So I'm going to go into here, and actually I was looking at that the wrong place. It's domain here, and it's going to create my iStorm in here, and will automatically implement the drink for me. That's great. And then now when I'm going to do get stock here, it will help me create that method, because now, drink is a known type for it and has to return me, an integer value. Okay, so this is vending machine. So, but once again, remember, right? We said that there's too much going on in the vending machine. Single responsibility, right? Okay, up to this point, the vending machine, this is why again? Okay, quick question. So why again is it in the domain package? I'm sorry, Carol Myers, if you can just maybe ask your question. I'm not sure what you mean by why again is it in the domain package. Well, okay. Oh, my bad. Yes, because it's again in the domain package, because a drink is just a POJO. It's just a plain old Java object that represents a business concept for me, right? It's a drink, right? It won't have behavior. It shouldn't have behavior. So if your object is just an object that contains data, right? It doesn't do any business logic within it, then it's what we normally call in the software world a functional object or a domain object. So that's why I'm creating a package, so that I can easily see where are my domain objects that represents my concepts, right? If that makes sense. So later on, I don't know how we're going to code this, but if we wanted to model the prices as an object and not just as a double or a float, for example, right? Then we might, and because it would just be containing a numerical value, we would also maybe introduce a concept of price here in the domain, right? So that I hope this answers your questions in terms of why we're putting that in the domain package. Okay, so contract, right? We're trying to approach this from the outside. We're saying to the vending machine, well, give me my stock, but the idea is always to delegate, right? It's like the vending machine is maybe like a controller class. Eventually, it will turn out to be like that, and it's going to delegate. So, and we're going to see how this is going to work, right? So, vending machine, get stock, drink, and you have to give me back my current stock of 10. Okay, so if you run this, remember our circle, our virtuous circle, right? We write a failing test. So right now, I just need to add a new method here that returns me a drink. Okay. We write a test, it fails, okay, and then we go and fix. So now we can write the implementation. Now we're allowed to go and write some code, okay, and then so we're gonna go ahead and get the stock, and I'm just gonna write 10 because I want it to just work like that, okay. Okay, fantastic. Now I've checked the stock of the drink, okay, and once again, it's through that same interface that the interaction will happen, where we are going to buy a drink, for example, right? So right now, to replenish the stock, right? So this is an interesting case here in Point. We haven't introduced yet a concept of a customer who can buy, who can buy a drink, because eventually we know that it's buying a drink that was going to diminish the quantity of the stock by 1, right? But we're going to be jumping the gun if we started to not write this. I mean, we could do that. That would be absolutely fair, but then our design might be going all over the place, right? So this is going to introduce a new concept now of how we're going to tackle this problem of, for the time being, how do we replenish the stock of a given drink, right? So somehow we need to show a way, right? We need to show a way of how we can maybe, so replenish the stock would mean what? So just if you think about it, right, it would mean that check stock replenish. Okay, so what does this mean? A replenish just means that I should be able to have some kind of method, set stock, right, for a given drink back to a certain quantity, right? For example, that's what it is. So how would we do that? An ideal way would have been for me to think about, if I had a service I could just inject into the vending machine, right? That would give me, let's say, a quantity of 5, and then I would just say replenish the stock to 10, and then I could just differentiate between the before and after. So I could just say get stock, and it would say, okay, you have a stock of 5 right now, ideally speaking. So what I would like to do, ideally speaking, right, is say get stock of drink, right? This would return 5, okay. And then I would say, okay, I would say then vending machine, replenish, right? And so yeah, so replenish stock, let's say. And then I would just say drink. So I wouldn't put a quantity because the quantity is by default 10. So the requirement doesn't specify anything else. So I'm just going to pretend that as soon as we call replenish, it just puts it back to 10, for example, right? So I could introduce this method here, this interface. So void replenish drink, okay? So I'm going to go back to my implementation here. I'm just going to introduce this new method here, okay? So, but from a testing point of view, right, this would just replenish, and then I would say again, current stock here, and then vending machine gets stock drink. Now this would be back to 10, right? This would return 5, return 10, right? So how would I do this then? This is like the main question, is that how would I assert that current stock is equal to 5? Okay, because that's where I would like to, or 9, but anything less than 10, basically, because the reason why we're doing this, right, is that I don't want to go and implement, by, because then that's making me drift too far away from my requirement, right? That's already bringing me in the user interaction section, a part of the system, whereas I just want to first finish the maintenance part of it, right? That's where we started from. So how could we do that, right? And so some way, I mean, you could argue, well, Amir, you could just go in here, right? Couldn't we just go into the concrete implementation and just say, hey, the stock is 5, right? And I'm saying, okay, that's very true. That would work, but then I haven't really solved the problem because my business case is asking me to have a capacity of 10. So then my other test would fail, obviously, right? This would not be equal to 10. So it's just, that's not a feasible situation. So this is, and once again, like you see how the test is again, stressing and having the other flag up in my head still saying, hey, single responsibility here. So what could we do? So we could say, well, this is the part where we start about separating concerns, and we're saying that actually the vending machine. So we started off, you see, with this consumer user interaction, and user not by saying a client as buys a drink. I'm saying user like anyone interacting with the system. And we can now introduce a concept here and say, well, what we're going to do in this case is let's create a vending machine. But when we create a vending machine, we actually provide it with the stock service. Okay, and the stock service in our system just handles the stock of the drinks. It knows, when the drink went down and when someone bought something. This is basically the gateway to kind of access this information. I'm like, okay, let's see if this can actually work out well or not. So we're going to introduce a concept of stock service. So we're going to the same way, right? Remember, we always write to an abstraction until we have to do otherwise. So new. So now I'm gonna go a bit faster. So I'm just gonna assume that you guys have understood the concept here. So I'm just gonna say soda pop stock service here, create. Okay. So I'm gonna create this class called soda, and making sure that it goes into core here. Actually, I should have maybe made a package called service, so we can later on maybe change this. So soda pop stock service. I'm going to create a static method here that's going to return this interface, right? So you can just see that the code is just coming to life, right? It's just coming, I'm never going, as you can see, since the start, we have never gone ourselves here, right? Everything is being driven by the test here. So we've got our stock service, and we're saying now that actually we want to provide a stock service to the soda vending machine. That's what it needs. And I'm going to show you why we're doing this. You're going to see the value of this very, very soon. All right, so we're going to add this dependency now into the vending machine. So we're going to go here and I'm going to say stock server. Just want to complete all of this now. All right, and now we have a new dependency here. Okay, stock service. We're going to come back to our, so we're going to just fix now. So we need to give it also a stock service. Okay, stock service, soda pop stock service. This is our other test, right, that we had. Okay, And okay, so why did we do this? So we're doing this because we wanted to be able to inject and separate the behavior of stock management into another abstraction that the vending machine will delegate, right? So when you inject something into a class like this, you're delegating, okay? You're using what we call aggregation or composition, which kind of models the idea of saying that a class is provided objects on which it will send messages, meaning it will call methods, to ask them to carry out more specialized tasks that they can handle, while the other class is acting more like a controller class and asking other people to do things, right? So for example, in the real life situation, you go to the post office and you give them your letter to say, okay, now I'm delegating to you, the post office service, to go and just deliver now my letter to wherever it should go, right? So you delegate, right? So it's the same way, single responsibility. We're just going to delegate the stock management to the stock service. For that, we're providing the vending machine a stock service. Okay? All right, great. But this is all well and good, but you're not helping me solve my problem of, 5 and how does it all work? So this, at this very moment, is a magical moment where you see why an abstraction is so important. So right now, this is like the default behavior, and this just returns a new soda pop service. Okay? That's so I'm just going to, so actually this did not implement yet the stock service, and this just returns the soda pop stock service. This is like the default implementation is not doing anything. But in the test, we did not care right now for this implementation. And you're like, wow, really? Like, what do we care about? And this is where the beauty is. Because we're using an abstraction, because we're using an interface, and we're not using a concrete type, this is what we can do. We can pretend, we can simulate because of abstractions. We can inject simulated abstractions, and let me show you how you do that. So we go into our test here, okay? And we're going to create another package here called stub. Okay, a stub, what does that mean in testing lingo is that it's a stand-in replacement with some hard-coded dummy values that you're going to use to test a specific scenario. So that way you don't have to plug in the whole system or part of a system. You can just provide a given input to say, look, if I gave you this vending machine, if I gave you this, then how would you behave? Like how would you react, right? So it's a very nice, loosely coupled to separate concerns and to be able to simulate many scenarios. So how does this work concretely? Well, what we're gonna do, we're gonna say, hey, we're gonna have a stock service stub. Okay, so this is going to be a concrete implementation. So we're going to create this. And we're going to put this one is not going to be part of our code. This is just used only for our testing purposes. So this is going to go into the stub package here. Okay, so it's going to end up here, right here, stock service stub, right? So we're just going to create a method here, public static stock service stub. And this implements obviously the stock service here. And we're going to create a heap object here. We're going to return the stock service stub. Okay. Okay. Now, but and you'd be like wondering why are we doing this? So we're doing this because we want to be able to inject a certain level of rather than implementing the add, buy, drink behavior straight into the vending machine, we're trying to break in and add in delegation to other types to achieve that goal without, going too far in our code. So how would we do that is that we would say, well, the get stock. So we've introduced this method. We had to anyways because we had to like introduce that concept of being able to check the stock and diminish it and replenish it. So for the time being, we went from the outside because the vending machine is the most outer layer with which the people interact when using our system. So that's why we went and we added this method. But recall that I said we could do it this way, or we could have just directly. This was the other single responsibility. The other class we would have started off writing, and then eventually we would have come back to this test and retrofit this in. So, but I thought that this is a bit more meaningful because you can visually see why you would need to do this and what's the rationale behind. So that's why I did it this way. So now, okay, that's all well and good. How do we get to the point to 5? Well, Now the stock, so we know that we have injected a stock service, right? So what we're going to do in here, we're going to say, hey, use stock service. So just bear with me, and you're going to see exactly how this is going to work. So we're going to say get stock, and we're expecting here 5. So this should be 5. And then when we replenish the stock for that same drink, this should go back to 10. Okay, so let's run this test. Of course, it's going to fail, right? Because I mean, already the 5 that's not true, right? So now what we're going to do? We go into the stock here, right? We go into the concrete implementation, and we're going to delegate now. So you see how we're delegating. We have the stock service injected. So now I'm saying stock service, and now I'm introducing get stock, and you can see that I'm mirroring here the same API call, because for the time being, it's just going to be very straightforward, because it's going to be a very clear redirection, a delegation, right? Okay. So I'm going to introduce now in stock. So you can see now that slowly we're trying to go towards now this new interface, and you're going to see how we're going to now nicely go into from the vending machine test into this the stock service test. So now we have this get stock. So now all implementing interfaces are going to be required to implement this. So for the time being, this is the concrete implementation, but right now we are working with a stub, meaning that we are trying to just give it that value we require. So right now I'm going to say the stock for any drink you give me is 5. Okay. So when we come here now, the vending machine has a stock of 5. Okay. But you're going to say, okay, well, this is all well and good, but this guy does not work anymore because you had hard-coded 10 earlier, right? And now this is breaking. So we know that, but you'll see how all of this is going to fit nicely together once we complete once we complete this test. You're just going to see how everything is just going to fit back into the picture very cleanly. So actually, one thing what we could do here, right now, we've been using the same vending machine object here, right? And I don't want to maybe complexify the code too much, so I'm gonna do a bit of duplication here. Okay, so just bear with me, but this is perfectly valid. So for the time being, our setup method is not going to. So we're just going to do this. We're going to say we're going to initialize ourselves the object each time in our methods. And you'll see why we're not doing it in the setup. It's because the first time, because this is the stub, I can pollute the creation mechanism here as much as I want. I have total liberty because I'm not impacting. This is just a testing class, so everything is allowed here pretty much. So I want to first give the parameter, the stock initial parameter here to my stub. Remember, a stub is just a drop-in replacement. It is only used for testing. That's why we call it a stub. It's just a dummy object, you know. So what does it do? It just returns me the quantity here. Okay. So I'm going to say quantity. So I'm just going to say the quantities here. Okay. So because of this, I can say create me a stub that has an initial stock of 10 here. Initial stock is 10. So this test passed. Okay. Passed, right? And now, but this time, if I had put this in the setup, obviously then this would also be 10, which I don't want. So I wanted to say I'm simulating the fact that my vending machine, when it was initialized with the stock service actually had an initial quantity of 5. Obviously, right now, all the drinks would have the same quantity, which is totally incorrect, but I'm paving the way to get to the test by working my way first through the vending machine, remember. So just stopping here for a moment. We could have very well said, we're not going to write a vending machine stock test. We're going to create a new class, a new test called stock service test. And first we would have written the whole logic and everything, right? And then came back. So I just found this was a bit more natural because we're trying to, you know, mold our vending machine interface, right? Because at the end, that's where everything's going to come and plug itself back together too. So coming back to our stock test here now, again, so We initialize now the vending machine with a stock service, initialize the value of 5. So now it will fail here and not here anymore. So let's rerun this test. And we're going to see that this, okay, I think I ran the debug mode rather than the execution mode. So I'm going to rerun this. Okay, so you can see now that actually is failing on the 10 now. So expected is 10, but you can see that the actual is 5. So now we are getting 5. The current stock of this drink is 5, right? So for us to be able to, now this test is working out well, it's starting to take shape. So now this replenished stock can be tested also in the same way, because the idea was just to have a delegation, but to introduce the first, to introduce these two methods, for example, right, of our contract, but to delegate to single responsibility. So now we're just delegating. So we're just going to, for the time being, until we are going to be required to, but until that point, we're going to keep the same names so that it's very clear for someone looking at your code that this is just a redirection. We're just delegating, right? So replenish stock on the stock service. So now you see that the replenish stock service right now is also now introduced. So we're going to go back to our stub, and the stub is just going to return, is going to return always the max value here, okay? So here, replenish stock. So actually, so what it's going to do, replenish is just going to say quantity is equal to 10, right? That because we just say that whenever we replenish, we just put the quantity back to 10. Now, obviously, right now, it doesn't want me to change it because the field is final. So we're going to remove the final, and now it's going to be 10, okay? Fantastic. So this is our vending machine, because right now the test is not about the stock service, right? Because if you look at the test, right, the test is, we're in test called vending machine stock test. So right now we just use these tests to introduce that API. So now if we ran this, I think I have a coding error, a compilation error here. So this cannot return a value from a method with return result y. Okay, so fine, I'm just saying return, that is fine. And we're going to run this, right? And we're just going to add that replenish method here, replenish stock. So for the time being, this is our concrete implementation. But remember, right now, the stock service was never under test. We don't care about the stock service. Remember, that's why we started out with a stub here, right? Remember, the stock service was never the point of interest at this point, because we're testing the vending machine that introduced a new API. So fantastic. So now we can see that actually the vending machine, when it's down, so if you come back to our good old requirement document here, right here. Oh, excuse me. There you go. So turn on machine, we've done that. Off also, replenish stock. All right, so this works. Retrieve cache. All right, so now same thing. So as you saw, we wrote a test again, right? And we're replenishing also the stock. It didn't say for us given drinks. So right now we're not stressing the code. We're not required yet to manage code yet for the drinks and everything, right? Because that would not be through the vending machine anyways, because the vending machine just has a nice right now API, just says get stock and replenish stock, right? For a given drink. And for the time being, that is sufficient enough to introduce the concept. But now we can go into the proper the stock service implementation, right? Because now we have enough, we have declared a full, like an outer skeleton now of our service to properly handle this. So now what we're going to do, is that we're going to now write a new test class that is only going to focus now on this stock service. So now I'm going to say stock service test, right? And now we're not going to care about anymore about our vending machine. Now it's going to be all about our stock service. So you see how cleanly we delegated first. We introduced the entry points. So we have our entry points now in the vending machine. We have our two ending points: replenish stock, get stock. We introduced the concept, and we updated our code to have so that we're injecting now a stock service, and now we can solely focus on the stock service, right? So we have already stock service. So soda pop stock service create. Okay, fantastic. So now because with a single responsibility, now we're going to properly add a system where we're going to be able to also now handle the stock for a given drink, right? So what we're going to do now, all right, fantastic. So what do we do? Well, we say test, and I want to get stock of all drinks. And you can see now how the API is going to be changed. Now how the API is going to change, and everything's going to fit in together nicely. You'll see. So now get stock of all drinks, right? I mean that's a valid method because we should be able to actually, you know what? For the time being, we don't need this, right? So we just want to say get stock of drink. Okay. So we say stock service. Okay. So I have to create this service here. Okay. Stock service, get stock. Okay, drink. Okay, so let's initialize our drink. Drink. What was it? Soda storm. Okay, ice storm. So same thing. I'm just gonna start using my good old pattern here. I don't like using new, so I'm just gonna create a new here. New ice storm. Okay, and I'm just gonna go here, and actually I'm gonna go here so that we cannot use the public constructor unless needed. So until a requirement makes me have a default constructor that's public, I'm making everything private. So this might have an impact potentially on here. So I'm just going to go and change this just to avoid any compilation error. Okay, so iStorm create, and maybe the other one here too. Okay, so we're going to come back here. So what is going to happen here? We have a drink. We have the iStorm drink. We're going to add. Okay, fantastic. And we want our stock. Switch statement. I want to get a stock. So this is going to be an int stock drink stock level. So what is this going to give me? Stock. We're going to go into the implementation, which is right here. And this is right now at 0, so I just want to have this to 10 because that is our default value. Remember, that's what. So I'm just going to close everything here, and I'm just going to have. I'm just going to open my test here. So this is the default value, right? So we said that as per our business requirement, it says capacity of 10, right? That's the maximum capacity. So when we create a new, only a new default initialize the service, the stock service, the default levels should be 10. Drink stock level is equal to 10. Okay, fantastic. So this should work, right? Let's write it. We wrote a test. I skipped a step here because I changed 0 to 10, so normally the test would have failed. Then I would have put 10 to make it pass, right? Okay, that's fantastic. How do we test? Once again, how do you stress this? How do you force? Because remember, we're not allowed to go and write a code ourselves. I cannot just go now and just write code here. We're not allowed to do that by using those 3 steps of TDD. You're not allowed to do that. You have to first write a test to have a justification to go and change. So how do you stress it? Think about how you do this, right? While I write the name, and if someone has an idea, just message that into the channel. If you have an idea, and don't be shy. Just there's no wrong answer. You can just if anyone, while I write the name of the method, go ahead. How would you stress this? How would you force right now? How would you force me to go and be able to write an implementation here of replenish stock, for example, or get stock, or just do something to this class? How do you force me to do that? How do I write a test that forces me to do that? Does anyone have an idea? Or have you guys all fallen asleep? So one way we could force, one way you could force the test for this to happen is that we could say, well, one way to do this is that we could say diminish, right? So simulate. So how can we say this? So drink reduce drink stock Okay, yeah, no worries. I understand there's a lot, maybe a lot of stuff going on. So reduce drink stock by 1, right? So we're just reducing the drink stock by 1. Which so remember now we're not on the vending machine interface anymore, right? We're on the buy a drink. Yeah, I like that. Buy a drink, right? So right, that's a very so Carol Myers, that's I like what you said. I like what you said because that's already making you think about, how you're thinking about user interaction and everything. But remember, that's what a user would do, right? And what we're right now working on is that we're working on a stock service. So a stock service conceptually does not directly deal with a user, right? What deals with the user is your vending machine, right? Your contract. So eventually, at some point here, we will indeed have a method here of our part of our contract that would be, buy drink, buy drink, for example. But it will maybe not be the vending machine interface. It'll be some other interface. So because this is a stock service, a similar concept that we could introduce is, a decrease stock by 1, for example, decrease drinks stock, right? So what we could do here is, I'm just going to duplicate this here, and I'm going to say sell by date. Okay, no. So just bear with me, and you'll see. So the idea is to say we're writing an API that's in line with what the current thing under test, the system under test. So here is a stock service under test. A stock service does not have, if you think about it from a business real world perspective, if you're Amazon and you have an interface that deals with your inventory, right? You would not be thinking my client is buying the inventory. No, you just have an inventory, and a product is just a product, right? So you're just checking inventory levels, for example. But if you're on the web service side of Amazon, right, when we log on to the Amazon website to buy things and browse, then the abstraction used on the front end on the web application, then they have a concept because it's a user that's interacting with them. So they will have user adds a product to a cart, user selects a product, right? But if you are writing software for their inventory, where all of the products go on their belts and their conveyor belts, and they're moved around on transports and stuff like that, then you don't have business users interacting with it, right? You have more crude operations that are more in line with logistics. So here you would say, if I had the drink, and I would say stock service, reduce, so sold, for example, so reduce stock of drink, right? Of drink. I'm going to reduce the stock of drink once, right? And then that stock level now should reflect 9, for example, right? So I'm just going to say create method reduce stock. So I'm going to go back to the implementations of this class. So we're going to go here. We're going to be adding this here. And then obviously I have to go into my stub here too. And for the time being, the stub doesn't matter what value it has, because right now that's not what's under test and we're not using it. So if you would reduce a stock of drink level, then it should be 9. Okay, so because it's a new method, I'm going to cheat again, and I'm just going to go to the straight pointer. I'm going to say return 9 because I'm lazy, and that is enough to make my test pass. So as long as that is true, I'm happy, right? I have to write a test to make me change that, right? So you can see that this test works, right? I created a drink, and we reduced the stock of drink by 1, and this gives me 9, and that is fine. So, well, you could say that if you've reduced your stock, you should maybe write your test differently and say, should maybe not write it this way, but then you should say stock service, and you should say stock service get stock of that drink again, and this should return you 9. So let's do that, and that will fail, of course. Okay, so this is good. So see, I'm stressing now the code. So now I know that this get stock and all this get stock cannot be hard coded anymore to 9. If I put 9, then the other test will fail. So now I have to do something about it. So how would I do that? Well, I can use So now I need to have some kind of inventory now. So now the stock service is going to have some kind of inventory, right? So what can we do? Well, we're going to use a construct like a map, right? So this is one of a construct in Java. For those who don't know, it's a dictionary. You can map a key and a value, right? So my value could be, so I can have an integer here so I'll basically this is just a a very simple dictionary, so a map. So this is going to be stock. So, and this is going to be a new hash map of string integer. So it's always good to put this into a private constructor and just, so we're going to put this into the constructor, private. And I'm not going to inject this value yet. At least I don't see the need for it. So I'm just going to put this as private. So always declare your member private unless otherwise required, but by default, always make them private final. Always have a good habit of developing that. Always make them private final. So I've created a stock, and I need to create now some kind of initial, maybe stock level, because otherwise, how would I know that this is 10, for example? So at this point, I need to create some kind of mechanism to initialize this stock. So I could say, for example, initialize. So when we create the stock service, we're going to initialize the stock map with some drinks. Okay, so we're going to create this method, and we saw that we had 4 types of drinks here. But right now, I'm just going to go for Ice Storm here. And I'm not going to care for the price yet. I mean, this is it's not required. The test is not asking for it. So I'm only going to write enough code that's going to make my test pass. Remember, you have to be lazy. Be lazy. This is one of those rare moments where being lazy is good. Okay, so I'm going to go back to my implementation, and I just need right now. I've just been testing with one drink, which is Ice Storm. So in my initialize method here, I'm going to say stock put. So this is going to be new, so Ice Storm create, right? And I'm going to put my initial quantity of 10 in here. Okay, so what does it say? It doesn't like what? So I gave a string where actually I'm putting a drink. So actually what I want is a drink. I'd rather just store the object, right? So drink here, and there's going to be a drink. So it's going to be a key, but that's actually not going to work, because if I put in a drink, then actually it is going to work fine, because so it's going to be a drink and their associated stock at a given moment, right? Okay, so remember, we're using a hash map. So this was what I talked about quickly in the last session video. So for those of you who didn't see my session, go and see it during the end. It's very important that when you're using a hash map, anytime you use hash map, it's very important for any class. I could have demonstrated this with the failing test, etc., but just for the sake of time, I just want to skip some parts of it. So whenever you're using an object as a key in a hash map or any hash set or anything that has to do with hashing, Java, the Java contract stipulates that you have to override the equals and hash code methods in your class, basically. So I'm going to insert these methods in here. So override methods equals and hash code. So I'm just going to so here we're going to do generate. How come it's not giving me the ability to? Oh, of course, but of course. So Ice Storm is going to have, let's say, a name. So we're gonna give this a name. Okay, so private string name, and this is called the Ice Storm drink. Okay. And we're just going to define that value. So we're going to add now an equals and a hash code method here. And you want this because the contracts, I don't want to wait. I would just recommend you guys go ahead and have a listen to my video, the last part of it, and look up yourself in your own time the equals and hash code method. Basically what this is that whenever you're using a hashing data structure, you need to provide this equals and hash code method because the Java collection libraries are expecting you to have overridden these methods so that when they are used to look up elements, so here a lookup will be done when you're going to say stock.getDrink, it will look up using those two methods and try to find the object and its associated value, basically. Okay? So now we have the stock initialized. And so if you want to get the stock now, we're going to say just from the stock, get the drink, right? And that drink will return us the value. So remember, a dictionary, a hash map is a dictionary. It's a mapping between a key and a value. So the key is the drink, and the value is right now this 10 or the stock level. So replenish stock. We know that the replenish stock would just say stock, put the drink, and just by default put it back to the full quantity, which is 10. Okay, and reduce the stock of the drink. So this is what we were testing, right? We wanted a 9 and it was 10 because 10 was hard coded. Well, in this case, what we're going to do is that we're going to say, well, we're going to get the stock value, right? We're going to say stock, get for that drink. This will return us the current stock. So int current stock level, right? So we're going to say, then we're going to reduce the level of the stock by 1, right? Because we want to reduce it by 1, right? So we're going to say stock put for the same drink. We're going to override that value, say current stock level minus 1, okay? And we can just return that value now. Say stock get drink because it's been overridden, right? So we have reduced the stock. So if you just rerun this test now, hopefully this should work, and it does. So now we have the stock that's being managed now properly with an internal state by the stock service. So we're going to continue our now test here. So we did what? We said get the stock of the drink. So let's see if this still works because we made some changes, right? So let's see. This seems to work fine. So we have a stock of 10 initially, which is great. Reduce the drink stock by 1. Okay, fantastic. So now how do we further stress test this? Well, same way. How you further stress this, you now add 2 in the mix. So you say reduce drink stock by 1 and check that another drink stock is untouched. For those who are thinking, man, that's a very long method name, that is fine. It doesn't matter. It's only the test. A developer can very well come and read this. You don't have to worry about it. You know that when you're reading this, it's very explicit, it's very crystal clear. You know exactly what's happening, right? So don't worry if it's too long. As long as it's meaningful and it's being and people can understand, that is much better. So we're going to do what now? We're going to create 2 stocks. We're going to say, so now we're going to go into the README again, and we're going to see, okay, what was the other drink? Desert Cold. Okay, so I wonder who came up with these names. Anyways, so Ice Storm and Desert Cold. All right, so Desert Cold is our new drink. Desert Cold. Okay, this class now. And this will go into the domain. All right, Desert Cold, that's fine. And same thing, we're just going to create that. And we're just going to say return new Desert Cold, right? And we're just going to implement drink. Right, okay, cool. And then I'm just going to say public. I'm going to say private Desert Cold. Desert Cold. And we're going to just say private string name. Desert Cold. Right? And same thing again. We're going to override the equals and hash code. okay? And we're going to come back here. So the idea was to say, well, we have two different drinks, Ice Storm and Desert Cold, and we want to make sure that one is not impacting the other, right? That's also a nice way to handle things. So if we reduce the stock of Ice Storm, right, in that case, I want to make sure that Ice Storm stock level, so Ice Storm stock level is equal to 9, but if we say Desert Cold stock level, in this case, get stock for Desert Cold now, right? Well, in this case, it should be 10. Obviously, it should not have impacted it because that was never, we never reduced the stock of that of Desert Cold. We just reduced the stock of Ice Storm. So assert that Desert Cold stock level is equal to 9. Okay. 10, sorry. So 9 because we reduced the stock of Ice Storm, but 10 because we didn't touch Desert Cold drink yet, right? To run this, we're getting a null pointer. You see, like, we haven't even written that much code, to be fair, right? And you can see that we're already, like, failing. So you can just see how the value of doing this by testing is so great, right? So why is this not working? So if we go in here and we just realize that, oh, of course, obviously, because we never added that drink, we never initialized, we never added, Ice Storm here, right? Sorry, Desert Cold. So now what we could do, right, we can just say now Desert Cold, and this would be a great opportunity now that the test would pass. This is a great opportunity to say, well, you know what, we're going to now delegate again. So this class, Soda Pop Stock Service, should not have to worry about maybe getting, maybe we could just like encapsulate all this into a factory, for example, and then that could further, even reduce further our code, and we could just delegate this small part of setting up the stock internally from this of the Soda Pop Stock Service. We could delegate that to a factory, for example. I'm not going to do this because in the interest of time, but we could further go and do that. So for the time being, this is working. So we needed to add also Desert Cold now. So we reran the test, and you can see that now that this is working, right? So this is great. And so we're going to do what? We're going to come back and we're going to run all the tests again. So we're going to do a right click here and say run all tests to make sure that we haven't broken anything. So this looks good, right? Everything seems to be humming along, and which is nice. All our tests are passing. So we've already got a little small, nice set of tests. And let's, let's run our coverage again and see. So, and you see it. So we're at 95%. We're 100% classes, 95 methods. So, and before we were at 100, so now you can see that we're losing a bit of coverage here, and we can actually go and see where that is exactly. So which are the methods where we're kind of now, and it will tell, the ID will tell you that, oh, well, actually you haven't tested with the red here. You can see that, well, you didn't test replenish stock yet, so we haven't tested that. So this is a good indication for us right now that if we thought we were done with the stock service test, well, then we should think again, because we haven't written a test for replenish stock, which is also because we have introduced that method. We should write one. So we're going to do that right now. So we're going to say replenish stock of drink. So replenish drink stock, right? All of this drink talk, I don't know about you guys, but it has made me very thirsty. I'm gonna go and have a nice cold drink after this session. So let's do this, right? So we're gonna say what? Okay, great. Let's do this again, right? So we're gonna create drink, and we're gonna get Ice Storm, and Ice Storm create, right? And we're gonna say stock service. We're gonna reduce the stock of drink of the Ice Storm, okay, by 1. And we don't need to test that again because our other tests above have already done that. But right now the test is focusing on replenish, right? So now we're going to say stock service, replenish stock of Ice Storm, right? And now if we do stock service, get stock of Ice Storm, and this should give us obviously 10, right? So ice storm stock level. Okay, and this now assert that ice storm stock level is equal to 10, right? That's what our condition was, right? So now we're going to run the test, boom, and see if this works. And it works, fantastic. So let's run that coverage again. So I think we're at 98% on some of the stuff. So let's go back to our we're back on 100% on method C. We were at 98, and now we're back on 100. So now we don't have any problem with replenish anymore. This was the method here. Remember, I don't know if you guys remember, but we weren't at 100% here. So this is good. And if we just look at the line here, where do we? So this is just on the POJOs, and testing POJOs, they'll get eventually tested. This must be the equals and hash code method. So you see, this is the equals and hash code method. It's fine. We can afford that. It's not all about getting 100% coverage. It's about getting good coverage on the main aspects. So methods, you should always worry about methods. The methods should have good coverage, right? If your POJOs don't have good coverage, it doesn't matter at the end of the day. The methods should have good coverage, all right? So we're good here. Now, where are we? So we did turn on, off, replenish stock of a given drink, retrieve cache. So this is now the other thing that we need to do. So retrieve cache. That's just like to know at what point how much money was made basically by selling. So I'm just going to skip this, and I'm going to go now to the user interaction, just in the interest of time. So we saw this maintenance interaction, and we saw this user interaction. Now, these two sections should raise a flag in your head saying, two different interfaces. And although both of them are going to be interacting with the same vending machine, they should have two different abstractions, appearances, if you will. And I'm going to show you how that works. So remember, in the requirement, they were saying that the company was saying, well, we want this maintenance capabilities from our technician staff. But we also want, obviously, the user-facing service, right? So let's come back to our vending machine here, and we have a look at it. So we saw that our vending machine is giving our overall, API of what can be done and what cannot be done, right? So it seems like right now we have written all of these tests have been focused on the maintenance part of the vending machine. So one thing we could do here, right, is that, and we can see that if we started looking at now the business part of it, so let's say if we wanted to see the price of a drink, before we write any code, we're going to refactor because we are allowed at this step because our last test passed. We're just going to structurally make some changes. The idea is to say that, actually this vending machine right here, what we should be doing actually is that we should be saying that this vending machine also extends another interface, another concept, which is the maintenance vending machine API, okay? A maintenance vending machine, right? So a vending machine is also a maintenance vending machine, right? And we can say that it also extends that interface. And the reason why we're doing that is that we're going to split actually our behavior. So we see that there's no common behavior right now between what a user can do and what a maintenance person can see. So let's make let's create one right now, common interaction, right? And the common interaction would be that a user, when they arrive in front of the machine, they can see the name of the company, and the maintenance person should also be able to see the name of the company. So actually the serial number, rather, no, let me see that. So serial number of machine is visible, okay? So you see that there's a common interaction, a specific user interaction, and a maintenance interaction. So when you see these kind of separate concerns in your head, you should always have a flag that goes on saying, oh, I need to have different signatures or different abstractions that are actually going to specify these behaviors, right? Remember, it's all about behaviors. OOP is all about modeling your behaviors, okay? So you saw that in the README here, like in the spec, we have maintenance interaction, user interaction, and common interaction. So this brings out a very nice, clean, maybe relation here where a vending machine is a common thing that everyone sees, okay? And the maintenance is what all of this is, what all of this is, and the user is going to be whatever new things we're going to make. So what we're going to introduce here, we're going to say create interface. And I'm going to go a bit quickly here. Sorry about like rushing things here because of interest of time. But so I'm going to extend, and this interface is going to extend another interface, which is going to be the maintenance vending machine. Okay, and we're going to, and we saw that all of these methods that we wrote were actually more to do with the the maintenance part of it. So I'm going to pull all of these up into the maintenance vending machine, and I'm just going to pull up all of these members because this is really the maintenance part of it, right? And the vending machine will also extend another one, which is going to be now the user, right? Because as a whole, the user vending machine, let's say, okay, and this user vending machine is going to have the methods or the contracts, interaction contracts, use cases that are specified here. So see the price of a drink, for example. So here we could say that, so this is going to return, let's say, so and this is going to be get drink price, for example, okay? And the vending machine for the common part, as we saw, will be get serial number. So if we come into here, the common part, which is the vending machine interface, it would say string get serial. Okay, so now if you go back to any of the implementations, we would not want to so I'm going to change this slightly. I'm going to actually, this is absolutely fine. Actually, this is fine. So this is going to get drink price and get serial. So here the serial would be, I don't know, let's make up some serial. This is the serial of our machine. Okay, so this is a common thing. So it should be available to both. Whenever we would want to use this, we would just use a vending machine abstraction for get serial. But when we wanted to be a bit more specific, so anywhere in our code where we would not want to expose, the maintenance commands, APIs, we could just pass in now a subset of the interface, so a subset of the API that the vending machine as a whole supports. So in some places where we only wanted to, take away the maintenance aspect so that in that code we cannot break anything, we can further enforce this by, rather than injecting a vending machine interface, we could just inject a user vending machine. So in this case, what would happen, for example, is that we could, for example, in this case, so actually, you know what? I've done this a bit incorrectly. I mean, this works also, but there's actually a better way to do this. The other way to do this would be, bear with me, is to turn this the other way around, and is to have actually two different, so it's to actually have the following. It's to say, we're going to break up our contracts, because if you look at the README, there are two distinct ways that a person can interact. If you're a technician, you're going to be interacting it in this way. If you're a client, a customer, you're going to be interacting with this way. But if you're both, if any of them, you should also be able to have this. So we're going to split this in user vending machine with only the business interface here, right? And the maintenance part of it. But both of them have a common, interface, a common behavior, which is the vending machine, which is the serial. So if the maintenance extends the vending machine and the user also extends the vending machine, right? They both inherit the serial, which is what the business wants. the common interaction for both is serial. So you see how we have cleanly now separated the business aspect with the user vending machine and the maintenance aspect with the maintenance vending machine, and the general global aspect, which is just vending machine, which is a serial, right? Now, we haven't added any behavior. We just need to go and change now our abstractions and our methods. So one final thing that we're going to do, because unfortunately time is already up. I can't believe that we're already done here. So I'm just going to go and just change in our everywhere where we were using the vending machine. So here, this is going to be a machine vending interface, and I just need to go and update the different import statements where we're using. So this actually is going to be machine maintenance machine, and this is going to be the same thing. This is going to be a machine maintenance, vending machine, and this is going to be same thing. Maintenance vending machine state and maintenance vending machine state, and the stock service. We're good. So let's rerun all the tests again to make sure we haven't broken anything. I think we have broken something here. So let me just rerun this. Okay. So now, just to show you a quick overview of this, if you look at the diagram now, we went from if you just look at this part of the diagram, the upper part of it, you can see that before we started off with just one interface, the vending machine, but now, so if I just put in also the methods here, so that will give you a bit more perspective, you can see that the vending machine now, before it had all of this methods, right? But because our requirement was very clearly demarcating between actions that a technician can do and what a customer can do, we now changed our approach and we said, look, the common behavior is in the common interface that's inherited by both, which would be to get the serial. So now any user could see on the machine the serial number, so that if they were not able to get a drink because they put in money but they couldn't get their drink, they could call the company and say, this was a serial of the machine that doesn't work. Then they could send out a technician to go and fix it. So now in your code, when we would write further, if we would be doing only maintenance work to further reduce any kind of mix-up with any kind of client-related action, we would then inject somewhere in our code, we would use a maintenance, vending machine type rather than user vending machine type, and that way we would block away all of these methods, and we would only see the ones that are necessary. I hope this part is clear. So unfortunately, I wasn't able to do the part with the user interaction. I'll see if I have time again. I hope that maybe I can do another part, and we'll continue from here maybe next week, and so that we can now finish this. And hopefully in the next session it'll go much quicker, so we might not even need 2 hours to do this. So we're going in the next part. Hopefully I'll definitely try to make this happen, and we're going to do the remaining part. And so yeah, so we're just going to stop here. I know this might have been maybe a lot of information to digest. So review again the video, and at a later time. And if you have any questions, please don't hesitate. You know where to find me, and send me those questions. I would really recommend that you go through again the whole video, and you do it also while I'm doing this, and at your own pace write this code. So now you already have the example. Just write it yourself as we go along to get the feel of this approach of saying, this is how I should be writing my code. I should never have to go first right here. I'm not saying it's easy. It has taken me. I've been doing this for a while now, so for me, it just flows naturally. But it is a bit complicated. So only practice will make you, get there easier. Okay. I hope this was a bit more clear for you guys in terms of figuring out how we do testing, how we write tests, how we think about breaking down to business objects, to interfaces, to contracts. And so yeah, have a good evening, everyone. And I hope you found this interesting. Please let me know the parts, especially that you did not find interesting. If there's anything that could be done better, please let me know. I'm always happy to improve the presentations and how I'm, explaining things. So definitely your feedback is more than welcome. Thanks for tuning in. I hope you found this interesting, and I hope to see you guys again. I'll definitely try to do another part again, so we'll finalize now the user part of it. Okay? Have a great evening, have a great night, and see you guys soon. Cheers.